In this particular example, we've been asked to find the derivative of the function 2x plus 1 all squared. This particular function can be expanded and written as y equals 4x squared plus 4x plus 1. To take its derivative in this form is merely a matter of using the power rule, and we obtain y prime is equal to 8x plus 4. I'm going to take that derivative and I'm going to place it up in the upper right hand corner for future reference. Now I'm going to take a look at this function from a different perspective. I'm going to leave the function in its original form, y equals 2x plus 1 all squared. If you look at the function in this form, you'll notice that it's a composition of functions. You have a linear function, 2x plus 1, embedded within a quadratic function. So what we're going to do is identify those two separate functions. We're going to let u equal 2x plus 1, and therefore y would be equal to u squared. We're now going to take the derivative of these two functions. When I take the derivative of the function u equals 2x plus 1, its derivative would be called du dx, and that derivative would be equal to 2. When I take the derivative of y equals u squared, its derivative would be called dy du, and we end up with an answer of 2u. According to the chain rule, dy dx is equal to dy du times du dx. So I merely substitute in the values that I worked out in the previous step. Dy du is equal to 2u, and I'm multiplying that by du dx, which is 2. Originally we had identified that u was equal to 2x plus 1. So I substitute 2x plus 1 back in for u. And then it's merely a matter of expanding that expression. I have a 2 times that 2x plus 1 times a 2. When I expand it, I end up with 8x plus 4. You'll note that this derivative is equal to the derivative that we had obtained using the power rule.